According to Section 210.8b of the National Electrical Code, all 125-volt, single-phase, 15 and 20 amp receptacles installed in bathrooms, garages, outdoors, kitchens, crawl spaces, unfinished basements, boathouses, hot tubs, and swimming pools shall have ground fault circuit interrupter protection. However, refrigerators and freezers are specifically exempted from this requirement. Therefore, the NEC does not require GFCI protection for freezers. Furthermore, most appliance manufacturers explicitly prohibit plugging their appliances with compressors, such as refrigerators and freezers, into GFCI protected circuits or receptacles. There are specific reasons for this recommendation. Firstly, compressors can draw high inrush currents when starting. This can cause the GFCI to trip, even if there is no actual ground fault. These are sometimes referred to as nuisance trips. Secondly, GFCIs can damage compressors if they trip repeatedly due to the high inrush currents, causing wear and tear on the compressor motor. In this instance, you are correct, the freezer should not be plugged into a GFCI protected circuit or receptacle. If the GFCI protecting the freezer is tripping repeatedly, it is important to have a qualified electrician troubleshoot the issue to determine the cause of the tripping and ensure the safety of the electrical system. Other types of appliances with compressors, such as air conditioners and heat pumps, are also typically not suitable for GFCI protection due to similar concerns regarding inrush currents and potential nuisance tripping. It is important to always refer to the manufacturer's instructions and local electrical codes for specific requirements and recommendations regarding the use of GFCIs with appliances. Remember that a GFCI is designed to protect people from electrical shock by detecting ground faults, which is when electricity flows outside of its intended path. While GFCIs are crucial for safety in many locations, they are not always appropriate for all appliances, especially those with motors that can cause temporary current surges. It is also important to note that there may be other electrical issues that could cause a GFCI to trip, such as a loose connection, damaged wiring, or a faulty appliance. If a GFCI trips frequently, it is best to consult with a qualified electrician to diagnose and repair the problem. They can test the circuit and the appliances connected to it to identify the source of the fault and ensure that the electrical system is safe and functioning properly. Therefore, the advice to not connect a freezer or refrigerator to a GFCI outlet or circuit is accurate based on both the NEC exception and the manufacturer's recommendations. The purpose of a GFCI is to prevent electrical shock, and while that is very important for humans, it can also cause damage to certain appliances if the GFCI trips unnecessarily, especially when it comes to refrigerators and freezers where it may cause food spoilage due to temperature rising. It's essential to balance electrical safety with the functional requirements of appliances to ensure both safety and operational efficiency. Also, keep in mind that electrical codes and manufacturer guidelines can change over time, so it's always a good idea to stay up to date with the latest information. If you are ever unsure about the proper way to connect an appliance to an electrical circuit, it's always best to consult with a qualified electrician. They can provide expert advice and ensure that the installation is safe and compliant with all applicable codes and regulations. When it comes to electrical safety, it's always better to err on the side of caution. Additionally, ensure that the wiring to your freezer is adequate. If you have an older home or building, you may be running undersized wiring that could be causing a voltage drop when the freezer starts up, which can cause damage to the compressor motor over time. It's also a potential fire hazard if the wiring is not adequate for the load that it is carrying. An electrician can inspect your wiring and determine if it needs to be upgraded to handle the load of the freezer. Ensure that the electrical outlet that you are plugging the freezer into is in good condition. Older outlets can become loose and corroded, which can cause a poor connection and increase the risk of electrical shock or fire. If the outlet is damaged or worn, it should be replaced by a qualified electrician. If you are using an extension cord with your freezer, make sure that it is a heavy-duty extension cord that is rated for the amperage of the freezer. A light-duty extension cord can overheat and cause a fire. It's also important to avoid using extension cords whenever possible, as they can be a tripping hazard. A dedicated circuit is recommended for the freezer. It's also worth noting that some newer freezers and refrigerators are designed to be more energy efficient and may not draw as much inrush current as older models. However, even with newer appliances, it's still generally not recommended to plug them into GFCI protected circuits. Firstly, the NEC 210.8b exception exists for a reason, and secondly, manufacturers typically advise against it due to the potential for nuisance tripping and compressor damage. Furthermore, depending on where the freezer is located, there may be specific electrical codes or regulations that apply. For example, if the freezer is located in a garage, there may be additional requirements for GFCI protection. It's always best to check with your local electrical inspector or a qualified electrician to ensure that your electrical system is compliant with all applicable codes and regulations. Finally, proper maintenance of your freezer can also help to prevent electrical problems. Regularly clean the freezer to remove dust and debris that can accumulate in the motor and other electrical components. Also, check the power cord for any signs of damage, such as cracks, fraying, or exposed wires. If you notice any damage, replace the power cord immediately. To summarize, while GFCIs are essential safety devices in many areas, they are generally not recommended for freezers or refrigerators due to the risk of nuisance tripping and potential damage to the compressor. It's always best to follow the manufacturer's instructions and consult with a qualified electrician if you have any questions or concerns. Also, regularly inspect your electrical system and appliances to ensure that they are in good working condition and safe to use. Remember, electrical safety is paramount. So when it comes to freezers, remember the NEC exception and manufacturer's recommendations against GFCI protection due to potential nuisance tripping from inrush currents damaging the compressor. Always consult a qualified electrician for specific concerns or code interpretations, especially in areas like garages where additional regulations might apply. Regular maintenance and inspection of your electrical system and appliances is important too. Always prioritize safety. Now let's delve a bit deeper into the technical aspects. Firstly, inrush current, also known as surge current, is the instantaneous high input current drawn by an electrical device when it is first turned on. For devices with motors like freezers and refrigerators, this inrush current can be significantly higher than the normal steady-state current. This surge is because the motor needs extra current to overcome inertia and start rotating. Secondly, GFCIs work by monitoring the current flowing in the hot and neutral wires of a circuit. If there's a difference of just a few milliamperes between these currents, it indicates that some current is leaking to ground, meaning there's a ground fault. The GFCI then quickly trips the circuit to prevent electrical shock. The sensitivity that makes GFCIs great for preventing shocks also makes them prone to nuisance tripping with motors, where inrush current briefly creates an imbalance that the GFCI interprets as a ground fault. Thirdly, the repeated tripping of a GFCI can indeed be harmful to a compressor motor. Each time a motor starts, it experiences mechanical and electrical stress. Repeatedly starting and stopping the motor due to GFCI trips increases the stress, potentially shortening the motor's lifespan and increasing the risk of failure. Fourthly, the National Electrical Code serves as a widely adopted standard for safe electrical installations. While NEC 210.8b provides an exception for refrigerators and freezers from GFCI requirements, local amendments or specific interpretations can vary. So consulting with local electrical inspectors or a qualified electrician is crucial. Fifthly, appliance manufacturers design their products with specific electrical characteristics in mind. Their recommendations against using GFCIs with certain appliances are based on extensive testing and analysis to ensure optimal performance and longevity of their products. Always heed these recommendations to avoid voiding warranties or causing damage to the appliances. Sixthly, if a GFCI repeatedly trips even without a freezer or refrigerator connected, it indicates a potential problem within the circuit itself. This could be due to damaged wiring, loose connections, or other electrical faults. Troubleshooting by a qualified electrician is essential to identify and resolve the underlying issue. Seventhly, While it's generally not recommended to use GFCIs with freezers and refrigerators, there might be specific situations where GFCI protection is required by local codes, especially in damp or wet locations. In such cases, using a non-GFCI outlet is not an option. You should consult with an electrician to explore solutions like using a time delay GFCI designed to tolerate brief current surges. 8. It is beneficial to understand that not all GFCIs are created equal. Some GFCIs are more sensitive than others, and some are designed to be more tolerant of inrush currents. When dealing with appliances that may cause nuisance tripping, consider using a GFCI with a higher trip threshold or a time delay feature, but only if it complies with local codes and manufacturer recommendations. 9. When an electrician inspects a GFCI issue, they often use tools like a multimeter to check voltage and current levels, an insulation tester to detect insulation breakdown, and a circuit tracer to map out the wiring and identify potential faults. This thorough approach ensures that the problem is accurately diagnosed and resolved. 10. Grounding is a critical safety aspect in electrical systems. It provides a low resistance path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and interrupt the power supply. Ensure that your freezer and refrigerator are properly grounded to minimize the risk of electrical shock and equipment damage. 11. Surge protectors are designed to protect electronic devices from voltage spikes that can damage sensitive components. While surge protectors don't prevent GFCI tripping, they can provide an added layer of protection against power surges caused by lightning or other electrical disturbances. 12. Arc fault circuit interrupters, or RSIs, are another type of safety device that protects against electrical fires caused by arcing faults. While RSIs are not typically required for freezer circuits, they can provide additional fire protection in areas where there is a higher risk of electrical fires. 13. It is worth emphasizing that electrical codes and regulations are constantly evolving to improve safety and address new technologies. Staying updated with the latest code changes is crucial for electricians and homeowners alike to ensure that electrical systems are installed and maintained safely. 14. When selecting a location for your freezer, consider factors like ambient temperature and ventilation. Placing a freezer in a hot or poorly ventilated area can increase its energy consumption and reduce its lifespan. Proper ventilation allows the compressor to operate more efficiently, reducing the risk of overheating and electrical problems. 15. Avoid overloading electrical circuits with multiple appliances. Each circuit is designed to handle a specific amount of current. Overloading a circuit can cause the circuit breaker to trip, and more seriously, it can overheat the wires and create a fire hazard. 16. Regular maintenance of your electrical panel, including checking for loose connections and signs of corrosion, can help prevent electrical problems and ensure the safe operation of your appliances. Electrical panels should be inspected periodically by a qualified electrician. 17. DIY electrical work can be dangerous if not performed correctly. Unless you have extensive knowledge and experience, it's always best to leave electrical work to a qualified electrician. They have the training, tools, and knowledge to ensure that the work is done safely and in accordance with all applicable codes and regulations. 18. Electrical safety training is essential for anyone who works with electricity, whether it's an electrician, a homeowner, or a maintenance worker. Training programs cover topics like electrical hazards, safe work practices, and the proper use of safety equipment. 19. When troubleshooting electrical problems, always de-energize the circuit before working on it. This means turning off the circuit breaker or removing the fuse that supplies power to the circuit. This will help prevent electrical shock and injury. 20. Use appropriate personal protective equipment, or PPE, when working with electricity. This may include items like insulated gloves, safety glasses, and arc-rated clothing. PPE can help protect you from electrical shock, burns, and other injuries. 21. Remember that electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. By following safe work practices and taking precautions, we can all help to create a safer environment for ourselves and others. In summary, While GFCIs are critical for preventing electrical shock in many areas, they are generally not recommended for use with freezers or refrigerators due to the potential for nuisance tripping and damage to the compressor. It is essential to follow the manufacturer's instructions and consult with a qualified electrician if you have any questions or concerns. Regular inspection and maintenance of your electrical system and appliances can help to prevent electrical problems and ensure your safety. Be mindful of inrush current and local amendments of the NEC. In the vast world of electricity, knowledge and caution are your greatest assets.